Let's continue. Now I would like to relate these three roots in another diagram, which is called the enthalpy change cycle. Enthalpy change cycle. Okay, in the cycle, we are not going to consider whether it is exothermic or endothermic, because for enthalpy level diagram, for endothermic we will pointing the arrow upward, for exothermic we will pointing the arrow downwards, but in the cycle it is not necessary. Now first of all, I will draw root A. This is root A with reactants are carbon graphite and hydrogen. Okay, for root A, the products are ethane with delta H equal to negative 84.7 kilojoule per mole. This is root A. And then next, root B. I will color root B in red. Okay. Now this is root A in green. For root B, first of all, C2H2 are produced. Okay, now in balancing the equation we need only one H2. That means two H2 haven't been reacted. That is the first step of root B. And then the second step is the formation of ethane from these two reactants. For the first step, we have 226.7 kilojoule per mole. And then for the second step, negative 1311.4 kilojoule. I will highlight these two in red. Okay. And then the last step, last root C. Formations of C2H4. 2 moles of hydrogens are used. That means 1 mole of hydrogen is left behind. After that, ethane is formed. The first step of root C is 52.3 kilojoule per mole. And then the second step is negative 177.0 kilojoule per mole. I will highlight them in yellow. Okay. Now there are 3 roots, A, B, and C. The overall enthalpy change is the same, regardless of the route by which the reaction takes place, provided that the initial and final states are the same. Understand? It's very useful. The cycle is very, very useful. Next, now these three routes can be related by using enthalpy level diagram. Sometimes it is called energy level diagram. That is the first way to relate these 3 reactions together. The second way is by using enthalpy change cycle. Okay, now I would like to show you the third way to relate these three equations together. Here we have root A, okay, which is a one-step reaction. And then root B, there are two steps. I copy down first. Bear in mind, dates are very important. Don't miss them. The first step of root C, it is root C. I show you root C first. The first step of root C have a positive value, positive 52.3 kilojoule per mole. And then the second step of root C have negative 137.0 kilojoule per mole. Now I will sum them up. Sum means these two equations up. In summing the equation, you can see that there is one C2H4 on the product side, and there is one C2H4 on the reactant side. In other words, we can cancel out these two. Okay? Then after that, we have two carbon, 2 H2 combined with 1 H2, we have 3 H2, and then C2H6. In summing up these two equations, also sum up the enthalpy change, which is 52.3 minus 137. Use your calculator. It is equal to 84.7 kilojoule, which is exactly equal to the enthalpy change for root B. Do you understand? Now, how about root B? Now, first of all, I copy down two steps first, and also their enthalpy change. For the first step of root B, this is the first step of root B with delta H plus 226.7 kilojoule per mole. The second step of root B, the second step of root B has a value negative 311.4 kilojoule per mole. Again, I would like to sum them up. In summing up, we have one C2H2 gas on the product side and one C2H2 gas on the reactant side. Cancel them out. Finally, this is the equation for root A. Then work out the overall enthalpy change. 226.7 minus 311.4. Again, use your calculator. It is 84.7 kilojoule. Okay? Now, in other words, there are three approaches to relate these three roots together. This is the first approach, drawing an energy level diagram. Endothermic, you should pointing upwards. Exothermic, pointing downwards. The second method, okay, which is called the enthalpy change cycle. It doesn't matter, okay, simply relate them together, okay. And then the third method, by doing summation to work out the overall reaction. And then next, you can simply do the summation on the enthalpy change to work out the overall enthalpy change. You can see that all are the same.